Hi there, folks. This is the review for the final exam, and as always, I am the amazing Mr. Jansen, so away we go. If we look at this first one, it's asking us just to simplify the expression, and here really we want to kind of follow order of operations as best we can. I'm going to start inside the parentheses. Inside the parentheses, I've got division, and there's not really much I can do with this division except change that negative exponent. Remember, negative exponents get sent to the denominator and become positive, so it becomes a 2 z to the third x squared. And now if I raise everything to the third power, 5 to the third power is 125. 2 to the third power is an 8. And now with the exponents, when I raise something to a power, I multiply the exponents. This is like a y to the first, so I do that. It's going to be a y to the third. This is going to give me a z to the ninth and an x to the sixth, and that's it. Number 2, it asks me to write an expression that can be simplified to this value. And really, there's plenty of answers that you could have here. You could do something very simple working backwards. For the 2, we could talk about doing just some division here and maybe doing 4 over 2. That would give us the 2 in the numerator. From m to the third, we could use some kind of division also. Maybe an m to the fifth divided by an m to the second. All right. For something like an n to the fifth, to get an n to the fifth in the denominator, we'd have to have something like an n to the, let's say, seventh, and maybe an n to the second up here. So just think about how these things cancel. And again, there are multiple solutions to this one. This is just one example. You could use multiplication, working backwards. When you multiply, you have to add the exponents. Divide, you subtract the exponents, that kind of thing. As long as it simplifies to the original problem. Okay? Number 3, it says to simplify the expression. And here we're subtracting, which I would always change subtraction to adding the opposite. And when we do that, now we're just combining like terms. Right here, this one doesn't have any like terms, so it stays as an 11x to the third. The x squared doesn't have any like terms either, so that's going to stay as a 2x squared. The negative 13x and the negative 5x can combine to a negative 18x. And then the 2 and the negative 12 combined to give me a negative 10. And that's it. So again, change subtraction to adding the opposite, combine like terms. Number 4, it gives us this equation. It's looking for us to express the growth rate. And it's really important here that we denote that it says growth rate and not growth constant. Or growth factor. As for this one, the growth factor is 1.22, but remember we get that by doing 1 plus the growth rate, which means the growth rate is just the 0.22. Okay, so that's the growth rate. In other words, it's 22%. So the growth rate is 0.22. The growth factor then is the 1.22. Number 5, it says to simplify the expression. Remember, we're looking for perfect squares that divide evenly into this. So 98 I can break down into 49 times 2. N to the 11th, remember, for exponents, to be a perfect square, it just has to be an even exponent, an exponent that's divisible by 2. So I'm going to break it into n to the 10th times n. And now I'm just going to take the square root. The square root of 49 is a 7. Goes to the outside as a changed number on the outside. The square root of n to the 10th is n to the 5th. It's a changed variable on the outside. And now underneath my radical, I've still got a 2 and an n left underneath there. Okay? For the next one, we're multiplying. When we multiply, remember what's outside multiplies by what's outside, what's inside by what's inside. So when I do this, it's going to give me a 2 square root of. Since the 2 and the 12 that are underneath are both underneath, we're going to multiply. That's a 24. And then a times a to the 7th is a to the 8th. And now we just got to break this down into perfect squares. That's the square root of this is going to be a 4 times 6. And then a to the 8th is already a perfect square. So now I take the square root of each perfect square. The square root of 4 is a 2, so it joins this 2 that was already out there. The square root of a to the 8th is a to the 4th. The 6 is still trapped. And now I just simplify this. I clean it up a little bit. That's a 4a to the 4th root 6. Okay? And number 7, it says to add these. And since we're adding these, we need to have like radical terms. We can't add them the way they are because one's a 12 and one's a 48. So I'm going to simplify this as far as I can. The 12 I can break down into 4 times 3. The 48 I can break down into 16 times 3. And now I just simplify. The square root of 4 is a 2. It jumps to the outside as a changed number on the outside. The square root of 16 is a 4, so it goes to the outside. It's a changed number on the outside. And now over here, I've got the 3 times 2, which is a 6. So I have 6 root 3 plus 4 root 3. Now, since I have like radical terms, I can add them together. It's going to be a 10 root 3. I add the coefficients. The radical part stays the same. Okay? For this one, it says, what is the GCF of the following polynomial? And again, that's greatest common factor, the largest thing that divides evenly into each of these. So I start with the numbers, the 12, the 16, and the 18. The largest number that divides into all of those is going to be a 2. And then when I look at the variables, I just take the smallest exponent that I have. For this one, it's going to be an m to the 3rd. And then for the n values, it looks like the smallest exponent I have is an n squared. So the greatest common factor is a 2m to the 3rd, n to the 2nd. In number 9, it says, what are the factors for the expression? And this we're just going to factor. I'm going to build a bridge. So two numbers that multiply together to give me a 12, but add together to give me a -7. It's a -3 and a -4. And now since there's a coefficient of 1 here, a leading coefficient of 1, I can use my shortcut. That means this factors into x minus 3 and an x minus 4. And that's it. Number 10, it says to use the quadratic formula to solve the given equation. So if I'm going to use the quadratic formula here, the quadratic formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I just have to plug this in. B is the 5, so opposite of that is a -5 plus or minus the square root of 5 squared minus 4 times a, which is 3, times c, which is a -1, all over 2 times a, which is the 3. I'm going to bring that down here. That's a -5 plus or minus the square root of. That's going to be 25, looks like plus 12, all over 6. And up from here, that's a -5 plus or minus the square root of 37 over 6. And I'm just going to leave my answer in that form for right now. Hint, hint, wink, wink, as a -5 plus or minus the square root of 37 over 6. I could plug this in and get my two answers and round them off, but I'm going to leave it that way for now. Okay? Number 11, it says a model rocket is launched from a roof into a large field. Path of the rocket can be modeled by this equation. X is the horizontal distance in meters, and y is the height above the ground. We want to know how far, what's the horizontal distance when the rocket hits the ground, okay? And when the rocket hits the ground, we already know one thing when it lands. We know that the y value, the height, is 0, okay? So in other words, I'm going to plug this in. Let me get rid of that. Let me write it correctly. Let me try this again. X squared plus 3.2x plus 4.9 equals 0. Okay, so I want to know when this thing is going to equal 0. There's a couple ways I can solve this. I can try factoring, but as soon as I see the decimals, that's probably not the best option. I could do completing the square, or I can use my quadratic formula. And that's the route I'm going to go. I'm going to do the quadratic formula. So opposite of b plus or minus the square root of b squared minus 4 times a, which is the -0.14, times c, which is the 4.9. And it's all over 2 times a, which is the -0.14. Okay, and it's really important just to be careful as you plug this into your calculator. I would do it in a couple steps. I would do what's under the square root first. I grab my calculator here, the 3.2 squared, and this is pretty safe to plug all in one shot. When I do that, I get a 12.984, and it's all over. I'm going to plug this denominator in as well. That's going to give me a -0.28. Okay, so just be careful plugging this in. That gives me a -1.44, and I get a 24.28. And really, one of these answers makes sense and the other one does not. The answer that doesn't make sense is the negative. The rocket's not traveling backwards. I want the positive distance. So that's it in meters. Okay? For this one, it says, what are the solutions? So the first thing you want to do is subtract the 12 from each side. So I subtract the 12. That gives me an x squared plus 4x minus 12 equals 0. And I'm going to solve this by factoring. I build a bridge. So two numbers that multiply to a negative 12 but add to a positive 4 are a 6 and a negative 2. So because I can come up with those, I can solve this by factoring. It's x plus 6 and an x minus 2. I can use my shortcut because I had a leading coefficient of 1. And now I set each factor equal to 0. And I solve each. The first one, I subtract the 6 from each side and find out that x equals a negative 6. The next one, I add the 2 to each side and find out that x equals a positive 2. So those are my two answers for this one, the negative 6 and the positive 2. Okay? Number 13, it says given A is 8 and C is 25, find the missing side B. So again, if this is 25 and this guy is 8, I'm just going to use my Pythagorean theorem, which is A squared plus B squared equals C squared. And so when I plug this in, that's 64 plus B squared equals 625. And now from here, and really it's important that you have the C in the right place. Now you're just going to subtract the 64 from each side. So you find out that B squared equals 561. And now from here, you just have to take the square root of each side. So I'm going to find out that B is approximately 23.69. Okay. Number 14, it asked me to simplify, so I just want to factor everything completely. In the numerator, I build a bridge, two numbers that multiply to a negative 10 but add to a positive 3 are a 5 and a negative 2. So that's going to factor into an x plus 5 and an x minus 2. In the denominator, that's a difference of squares, which factors into an x plus 5 and an x minus 5. Now that everything's factored completely, I cancel out any common factors, and it leaves me with an x minus 2 and an x minus 5. Okay. The other thing that this might ask us to do is state our restricted values by setting the denominator equal to 0. And since I've already factored this, I just have to set each factor equal to 0. And when I do that, I find out that x cannot equal plus or minus 5. And so that would be included as part of my simplified form unless it's not asked for. Okay?